quick video to demonstrate how to use this formula. The speed of light equals frequency times wavelength. So that's this formula right here. You can see these are the different units. They're also on your star chart. Also on your star chart under constants and conversions, you have this, the speed of light. 3 times 10 to the 8th meters per second. I'm just going to skip to a problem. So what is the wavelength of light? Wavelength being lambda. The wavelength of light that has a frequency, that's frequency, of 1.79 times 10 to the 15th hertz. So we have our formula, which is C equals F lambda. We need lambda, so I have to divide both sides by frequency. So lambda equals speed of light divided by frequency. So that's 3.00 times 10 to the 8th meters per second divided by 1.79 times 10 to the 15th per seconds. I chose to use per seconds here instead of hertz because then you can see that seconds will just cancel. And now it's a matter of putting it into our calculator. My calculator said something like 1.676 times 10 to the minus 7th, and that would be meters. Of course, I can't keep 4 sig figs here because there are only 3 in this number and 3 in that. So my answer should be 1.68 times 10 to the minus 7th meters. That's my wavelength. Okay, let's move on to a different problem. It says, what is the frequency of light that has a wavelength of 12 centimeters? Well, we do have a wavelength here, but it must be converted into meters. So I need to say 12.0 centimeters and then go, well, there are 100 centimeters in 1 meter, because that's what the equality is. A meter is 100 centimeters. So my centimeters will cancel off, and I'll end up at 0.120 meters is my wavelength. All right, I'm asked for the frequency, so I'm back to my same speed of light formula, C equals F lambda. But this time I'm trying to get rid of the lambda off the right side. So here we go. So frequency equals speed of light over wavelength. But don't forget, we had to do this. We had to turn our wavelength into meters because our speed of light is 3.00 times 10 to the 8th meters per second. I couldn't cancel centimeters down in the denominator. I'd have to have meters. In order to cancel the meters from the numerator, I'd have to have meters in the denominator. So that's why we did the conversion. So there you go. The meters will cancel off, but that leaves a 1 over the seconds. So that's going to give us units of per seconds. But let's put it into our calculator and find out what the frequency is. So the calculator says this answer is 2.50 times 10 to the 9th per seconds, or 2.50 times 10 to the 9th hertz. There's another kind of calculation we need to do. That has to do with energy of light. We have this formula here. Energy equals Planck's constant times frequency. And Planck's constant is given to you on the periodic table or on your star chart. Here's what Planck's constant is. 6.63 times 10 to the minus 34th joule seconds. It's not joules per second, it's joules times second, which we call a joule second. I'm going to go use that here in a second. So we need to know what is the frequency of light that has this many joules, and you'll remember joules are units of energy, per photon. We'll talk about photons, which are packets of light, separately from this video. Suffice it to say that light travels in little packets that we call photons, and each packet or photon contains a specific amount of energy. Okay, so this says what is the frequency? And we start out with the formula E equals, here I'm going to scoot the screen up, E equals Planck's constant times frequency, and I want to solve for frequency, so I have to divide both sides by Planck's constant. That means frequency equals the energy of the photon divided by Planck's constant. So in this case, we're given 1.96 times 10 to the minus 19th joules for every photon. I'm going to divide that by Planck's constant, 6.63 times 10 to the minus 34th joule seconds. You can see our units, after the joules cancel, are going to come out in per seconds, which is what they should be. That's the same as hertz. That's what the units should be when we get the math done with the calculator. Calculator says 2.96 times 10 to the 14th per seconds, or you could call that 2.96 times 10 to the 14th hertz.